You've just seen this tool that we're going to use, or this piece of information that says the limit as x approaches infinity of some constant divided by x to a positive rational number is 0. And that as long as x to that positive rational number is defined when x is 0, the limit as x approaches negative infinity of a constant over x to the r, or this positive rational number, is also 0. So let's see how we can make use of this piece of information to determine if the function f of x is equal to, in the numerator, 3x to the fifth minus x to the third plus x minus 1, divided by, in the denominator, x to the fifth plus 2x to the fourth minus 7x squared plus 3, has a horizontal asymptote. So what we're going to do is we are going to consider the limit as x approaches infinity of 3x to the fifth minus x to the third plus x minus 1 divided by x to the fifth plus 2x to the fourth minus 7x squared plus 3. And what we're going to do to make use of that piece of information that you've just seen is we're going to look in the numerator and the denominator. We're going to find the largest power that we ever see on x, which in this case is 5. And then we're going to choose to multiply top and bottom of this expression by 1 over x to the fifth power. And that will change the limit. So we have the limit as x approaches infinity of 3 minus 1 over x squared plus 1 over x to the fourth minus 1 over x to the fifth divided by 1 plus 2 over x minus 7 over x to the third plus 3 over x to the fifth. And notice how many of these expressions turn into ones of the form where we have a constant over x to a positive rational number exponent. So by what we've just seen, as x approaches positive infinity, each of these three terms goes to 0 in the numerator, and each of these three terms in the denominator also go to 0. So all we're left with is the limit as x approaches infinity of 3 over 1, which is 3 over 1, or just 3. If you do the same thing and assume x approaches negative infinity, we're still going to end up with exactly the same values. And by exactly the same process, the limit as x approaches negative infinity is also going to be 3 when we use f of x. So this function does have a horizontal asymptote. The horizontal asymptote is the line y equals 3. That's the horizontal asymptote that we end up with. As x approaches both positive infinity and negative infinity, the value of the function will approach 3.